Inside data centers around the world, a new kind of demand is taking hold. Generative artificial intelligence requires massive, multi-trillion parameter workflows, and feeding those models has ignited a trillion-dollar battle for global computing power. This diagram illustrates the phenomenon the tech industry is calling Ramageddon. As chip fabricators divert massive volumes of high-bandwidth memory and DDR5 RAM into the data centers of tech hyperscalers, the supply streams feeding standard industrial nodes are left practically empty. The impact has already reached the automotive sector. Modern vehicles require silicon for battery management and digital cockpits, but because automakers cannot match the high profit margins of AI cloud providers, their orders fall to the bottom of the ledger, leaving assembly lines stagnant. To protect their supply lines, major manufacturing consortiums across Japan, Europe, and Detroit are forming defensive purchasing alliances, attempting to secure whatever legacy memory allocations remain on the market. The focus on high-margin AI hardware is creating a hyper-concentrated reality, where entire traditional sectors are starved of the basic digital components they need to function. Far away from the noise of these terrestrial resource battles, a different kind of machine is at work. Voyager 1 is sailing silently through the absolute darkness of the interstellar medium, billions of kilometers from the planet that birthed it. While Earthbound industries fight over gigabytes of specialized memory, this spacecraft manages its entire mission on a total memory architecture of just 64 kilobytes. Operating at this distance is an exercise in patience. A radio signal traveling at the speed of light takes over 23 hours to travel one way. If a cosmic ray flips a single bit in its memory, the probe enters an autonomous safe state, waiting for intervention from a control room it hasn't seen in decades. This ancient, power-starved machine remains humanity's furthest presence in the universe, proving that even with extreme hardware limitations, the mission continues. Back on Earth, the bottleneck for modern processing power is held by a single company. ASML in the Netherlands has a commercial monopoly on the machines required to print the world's most advanced computer chips. Their latest leap is high-NA EUV. Instead of exposing a silicon wafer multiple times through complex stencils, a single precise laser strike prints the circuit at an 18-nanometer pitch. This process drastically compresses manufacturing cycle times and lowers defect rates, but it has also turned ASML into a geopolitical target. The United States has pressured the Dutch government to restrict these exports, attempting to block adversarial nations from accessing the technology. These restrictions have triggered a massive shadow market. In 2026, a federal indictment revealed that over $500 million in restricted AI hardware had been rerouted through international smuggling rings before the authorities could intervene. When the tools of technology are hoarded and restricted by decree, global trade begins to collapse into a series of shadow wars and structural sieges. For Voyager 1, the struggle is purely physical. The spacecraft is kept alive by the radioactive decay of plutonium-238. Thermocouples convert that heat into the electricity required to keep its core systems running in the freezing void. This graph maps the unyielding law of nuclear decay. Every year, Voyager's power generators drop by 4 watts. To prevent a voltage drop, engineers permanently shut down the low-energy charged particle instrument in May 2026, sacrificing 49 years of data collection to save enough power for the spacecraft's heaters and transmitters. To stop the mission from ending, JPL engineers deployed a software solution called the Big Bang. This systemic reset reconfigures how the spacecraft monitors and routes its remaining electrical current, aiming to free up a micro-reserve of power. Sustaining a mission for half a century in deep space requires the meticulous rationing of a dying power source. While Voyager survives on whispers of power, nations on Earth are pouring billions of dollars into building localized megafabs. They are racing to secure their own technological borders and reduce their dependence on Pacific shipping lanes. This push is fragmenting the global map. While the US and Japan focus on the most advanced chip fabrication, Southeast Asia and India are positioning themselves as the primary hubs for assembly and packaging. These high-tech facilities remain vulnerable to the physical world. They are dependent on stable fossil fuel corridors for power and require millions of gallons of ultra-pure water daily to rinse silicon wafers during the manufacturing process. A silicon curtain has fallen. Our digital infrastructure is not borderless. It is tethered to scarce natural resources and the physical limits of geography. On November 18, 2026, Voyager 1 crosses the 173.14 astronomical unit threshold, placing it exactly one full light day away from Earth. Here, the round-trip communication window becomes an ironclad 48-hour cycle. We wait 2 full days for any answer from the dark. Bolted to the side of the probe is the golden record. It carries greetings in 55 languages, the sounds of our world, and a musical legacy meant to outlast the civilization that created it. Long after the last plutonium atom decays and Earth's foundries are gone, Voyager 1 will continue its silent voyage. In 38,000 years, it will pass within 1.6 light-years of a star in the constellation Ophiuchus. While nations scramble to secure the newest semiconductors, our most distant representative is a 64-kilobyte machine, carrying the memory of our world into the night.